Good day. My name is Jill Slinger and I'm your course coordinator. I'm a faculty member and associate professor at the Faculty of Civil Engineering and Geosciences and the Faculty of Technology, Policy and Management. Yes, I hold a dual appointment. I also hold an appointment as visiting professor at the Water Research Institute at Rhodes University in South Africa. I've prepared this knowledge clip together with Dr. Helene Vreugdenhil, who works at Deltares and also has a part-time appointment at the Faculty of Civil Engineering and Geosciences. We have made a careful selection out of many topics that could be covered in dealing with governance aspects and building with nature. We'll focus on 3 aspects: issues of scale, multi-actor systems, and multifunctionality. Multi-actor systems and multifunctionality will be covered in the next knowledge clip. In this knowledge clip, we'll focus on issues of scale. But why is scale so important? Because you'll always face choices on scale. In this clip, we offer you an analytical tool that can help to clarify scale preferences of members of a multidisciplinary design team or even of your client. An infrastructural design project is typically presented at a particular scale, usually the scale of the client or problem owner. For instance, the dredging of silt from a harbour is often presented as a problem at the local scale of the harbour and of its immediate environment. Or the construction of a small dam for agricultural water is seen as only having a local effect. But a little farm dam, together with other small dams, can have a big impact at the river basin scale. It can contribute to urban water shortages and even have an impact on the natural environment downstream. This is happening in the Great Brook River in South Africa, and there are many such examples in South Africa, Australia, and in California. So, although it's very tempting to solve problems at the scale at which they're presented, it's the task of the engineer to sometimes broaden the scale and at other times to zoom in on the problem. To be a good engineer, it's essential to know when to zoom in or to zoom out. And this means that you know exactly at which scale you have to build your design. Since we're following the building with nature philosophy, this means that the materials we're going to use or the opportunities that we're going to provide for nature often require a scale different from the scale of the problem owner. So for instance, Helene Vreugdenhil studied the application of a building with nature concept called cyclic floodplain rejuvenation along the River Vaal in the Netherlands. She found that the personal scale preferences of the stakeholders determined where the morphological intervention was implemented. Basically, a secondary channel was dug on the floodplain near Boningen in an effort to rejuvenate the vegetation and to reduce the danger of flooding. Another place that could have worked to reduce the danger of flooding wasn't even considered seriously, owing to issues of scale. You can read more about this in the prescribed literature. In another example, I analysed the scale preferences of a range of stakeholders involved in implementing the 1990 Dutch coastal policy. This policy seeks to prevent the structural erosion of the Dutch coast by dynamically maintaining the coast at the 1990 position. This is done primarily through sand nourishments. Now I want you to have a close look at this diagram, the integrated scale hierarchy for sandy coasts. On the left-hand side, you can see the spatial and time scales associated with the biogeomorphology of the coast. Within the different layers of the diagram, the processes and the characteristics deriving from different disciplines are listed and are signified by letters. The integrated scale hierarchy for sandy coasts is an instrument that shows you on the one hand the biogeomorphological scale for the coast, and on the other hand the different scales adopted by the different actors. So for instance, a geologist characteristically considers longer time scales and more extensive spatial scales than most other disciplines. They see factors like coastal evolution, sand hunger, bar dynamics, but they don't necessarily see waves and rips. I found that it is the combination of people's disciplinary training and their tasks in coastal management that determine the scale at which they prefer to focus. The tasks in coastal management and policy implementation of the people that I interviewed are shown in the boxes on the right-hand side. This analysis reveals that the coastal policy was designed with a geomorphological scale perspective in mind. Have a look at the place of the red coastal protagonists at the top, at a very high scale level. But when it came to implementation, people with different, more local or regional perspectives were involved, indicated by the red star. This resulted in local adaptations to the policy and to regional differences in implementation. Using the integrated scale hierarchy for sandy coasts, you can show this. Let me be clear here. I consider this modification a strength of the policy implementation process. It's exactly this fine-tuning that makes the policy implementable. If you stick to the letter of the policy rather than the spirit, it's difficult to implement well, especially together with all the local and regional authorities. So, in the example from Beuningen and from the Dutch coastal policy, we encounter differences in stakeholders' opinions. These differences arise not only from their disciplinary training, but also from their tasks, such as being a river manager or a nature manager. So, two ecologists can have very different opinions on the desirability of a natural intervention. And for instance, two engineers can completely disagree on the desirability of sand nourishments. In working with nature, we have found that it is the combination of actors' tasks and disciplinary backgrounds that either gives them an affinity for the building with nature concept or not. But what does this mean for you as a hydraulic engineer? Well, to be a good hydraulic engineer, you need to know when to zoom in and when to zoom out. The integrated scale hierarchy helps you to choose an appropriate scale for your design. It's also an excellent instrument for comparing the different views of different actors. Thank you for your attention. I'll see you again in the next knowledge clip on multi-actor systems and multifunctionality.